Hey, and welcome to this 1-hour ROS2 Actions crash course. If you have started to learn ROS2 Actions and you still have trouble with them, or if you just learned some ROS2 basics and you want to go further with ROS2 communications, this video is for you. In this tutorial, I will explain why you need actions and how they work. Then you will directly generate your first action interface and write the Python code for an action server plus an action client. Here I will use Ubuntu 22.04 with ROS2 Humble, but this tutorial should also work with any other supported ROS2 distribution. Now, this tutorial is great to get you started on actions, and if you want to go further and dive into more details, work with feedback and cancel requests, create different goal policies, use actions with C++ and practice even more, then I have the perfect course for you, which contains more than 6 hours of video content just for actions. On top of that, you will also learn important advanced concepts such as lifecycle nodes, executors, and components. All of that in one single course that contains a total of 14 hours of video content. And to know more about this, you can find the course link in the description below. Alright, and now let's get started with ROS2 Actions. First of all, before we even get started with actions, let's understand why they exist and why we need them. After you understand this, I will explain briefly what actions are, and then we will dive into the details with hands-on lessons. So, why do we have actions? Well, to understand this, we need to take a step back. What are the communication features that we have with ROS? First, topics. Note that by taking this course, you should already be familiar with topics. So as a quick reminder, a ROS topic is a named bus over which ROS node exchange messages. Publishers will publish data on a topic, and subscribers will subscribe to the topic to receive the data. Note that publishers and subscribers are not aware of each other. So in the end, topics are perfect to send data streams in your application. Then the second communication feature are ROS services. The ROS service is basically a client-server system. The client sends a request to the server executes or computes something, and returns a response to the client. To put it into a nutshell, you will use topics for sending data streams and services for client-server communications. So that should be all, right? What else could we need? Well, that's actually how it started with ROS. At the beginning, there were only two kinds of communications, but ROS developers and users quickly realized that for robotics applications, something was missing. And let's see that with an example. Imagine now that you have a mobile robot with two wheels. In this example, we have a client node and a server node. The server node is controlling the wheels. What you want to do is to send a request from the client to the server node to say to the robot, for example, move to X and Y coordinates. What communication would you need here? Well, services seem to be the answer. So you could have a move robot service that will receive coordinates from the client, and once the command is received, the controller will start to move the wheels. And when the robot has reached the destination, the server will return a response to the client. So what's wrong with this? Well, moving a physical part of a robot in space can take some time, maybe a fraction of a second, but also maybe a few seconds or even a few minutes. The point is, the action can take some time. Services in ROS2 are asynchronous, so the client is not stuck during this time, but still, while the robot is moving, there are a few things you could want to do, and those things are actually missing here. For example, how to cancel the current execution. That would seem a reasonable feature to have. After you start the execution, you might want to cancel it. For example, the client node is also monitoring some buttons that a user can press. If a user presses the stop button, then in this case, the client can't do anything but wait for the server to completely finish the execution. Then, as the action is taking some time, it would be nice to also have some kind of feedback. Because with this service, well, the client has no idea what's happening on the server side. So the client is completely blind and needs to wait for the final result to know what's going on. And last point for now, although we could find many other points, how could the server handle multiple requests? Let's say you have 2 or more clients, each one is sending one request. Then how can you possibly choose between those requests? How can the server refuse to execute a request? How can the server choose to replace a request by a new given request without finishing the execution of the first one? Or in other scenarios, how can the server handle multiple requests at the same time? As an analogy, when you download files on your computer is not stuck with just one file. It can download multiple files at the same time. You have a feedback also on the percentage of the file that's been downloaded, and you can even decide to cancel one download while the other ones are still running. So if we come back to our example here, then you can see that a simple service is not enough. On top of that, we would need to implement some other services, for example, one to cancel the request, and also implement some topics to send the feedback to the client, etc., etc. And well, the good news is all those problems are solved by using ROS actions. So to conclude here, you would use topics when you want to send data streams between nodes. With topics, you don't really care about who is sending the data and if the data is being processed by other nodes. Then services are perfect when you want a client-server communication, but also if the action to execute is very quick. For example, a computation or a simple action like switching on an LED. And finally, for anything that needs a client-server communication, plus that will also take some time, and when you could want to also have mechanisms such as cancel and feedback, then actions is what you need. Now that you know why we need actions, time to understand how they work. Let's use the previous example with the wheel controller, and this time using actions. I will show you how actions work at a high level, and then in the following lessons, we will dive into the code to see the implementation details step by step. So on the left, we have our client node, which contains an action client, and on the right, we have our server node, which contains the action server, and this is also controlling the wheels of the robot. So what is the flow of execution of an action? Well, first the server needs to receive something, okay, it needs to receive an instruction. So here the action client will first start by sending a goal. Okay, so for a service, we're gonna talk about request and result. For an action, we're gonna talk about a goal. Okay, so what you send as a request for an action is called a goal. So the action client is sending a goal to the action server. Here, for example, move to those coordinates. The action server is going to receive this goal and it's going to either accept it or reject it. So let's say that the goal is not valid or the action server doesn't want to accept it, then it's gonna send a response to the client directly saying rejected. Okay, so if this is rejected, end of the story, there is nothing more to do with this goal. Okay, but if the goal is accepted, then the action server, so here the goal is arriving here, the goal is accepted, the action server will start to process the goal and execute what needs to be executed. And also one other thing is that when the client, so immediately after the goal has been accepted, the client receives a notification of that. And what the client will do is send a request result. Okay, so if the goal is accepted, the client will send a request result to the server. Okay, and it will wait here, it will wait until the server is done with the execution. And when the server is done with the execution, then the server will send back the result to the client because of this request here. Okay, so the flow is this. First, the action client sends a goal, then the goal gets accepted or rejected. If the goal is accepted, then the client will send a request to get the result. In the meantime, the server will execute the goal, and at the end, it will send the result of the action to the client with this request here. And so this is the minimum functionality that you have for a server. Okay, you're sending a goal, and then you have a request for the result. Then what you can add on top of that, and this is optional, you can add some feedback, which means that the server, while doing the execution, can send some feedback. And the feedback will arrive so the client can get the feedback and know, for example, here, it could be a percentage or it could be the current position of the wheels, etc., etc. So this is something that you can define when you create the action. On top of that, well, the action can also decide to cancel the goal. So there is a cancel mechanism. So at any point, so after the goal has been accepted, of course, then it's being executed by the server, and the action client can decide to say, okay, can you cancel this goal, please? And then the server, well, in the server, you can also decide what to do with this cancel request. Maybe you accept the cancel request or not. And if you accept the cancel request, then you're gonna finish to process the goal. So maybe you cancel the goal, and in the end, you also gonna send a result. So if the client here sends a goal and it's accepted, it's gonna send also a request for the result. In the meantime, the server starts to execute the goal. It will maybe send some feedback. The action client can also send a cancel request. And if the cancel request is accepted, the server will finish the execution. And in the end, either the goal is succeeded or failed or cancelled. In either way, the server is also going to return a result to the client. So the client will get notified at the end of the final result and the state for the goal. So that's how it's working. And there is actually one more thing, one more communication here. It's the goal status. So the action server, so each goal, we're gonna see that a bit later, but each goal has a status, okay? And the server will also publish the goal status. So at any time, we can know what is the status for the goal, but we're gonna see this one is not so important. Okay, and now that you have this here, you can see that I have put some communications here in red and some communications in green. Well, this is because what's happening behind the scenes is simply that, so what you see in red are services, and what you see in green are topics. So for an action mechanism, there are 3 services and 2 topics, okay? The first service to send the goal, and then another one to cancel a goal, and another one to get the result for a goal. And there are 2 topics, one to send a feedback and one to send a goal status. And so that's what is being implemented in ROS2 Actions. And the good news is, well, no need to create those topics and services yourself because they are already implemented in the client and the server classes, okay, with both Python and C++. So everything that you see here, you actually don't really need to worry about creating topics, services, etc. You have directly, well, you have some functionalities in the client class and in the server class of the action that you can directly use. So you might have to implement some callbacks and stuff like that, but you will not directly interact with the services and the topics. This is handled for you by the action functionality. Okay, and so I'm gonna keep using this image actually for the following when we write the code so that I can explain step by step what we are doing. And I'm just gonna simplify the image a bit like this. Okay, so you can see here we have the 3 services and the 2 topics. And I'm also going to remove this goal status here because the goal status is just here for introspection purposes. Okay, we don't really need it and we are not going to implement it. So in the end, what you really need are those 3 services and this 1 topic here. And I'm also going to put them like this because the feedback mechanism and the cancel mechanism are actually optionals, okay? So the only thing you need to do, the minimum required thing for an action to work is, so on the client side, to send a goal, and then if the goal is accepted, to send a request for the result. And on the server side, you need to be able to receive goals, and then decide what to do with them, and then execute the goals, and then send the result. That's the minimum thing you need to do, and then you can add the feedback mechanism, and then the cancel goal mechanism. Okay, so that's what we are going to implement in the code in the following lessons. And one more thing is, you can see here we have only 1 client and 1 server, but you can have several clients if you want. So you can only have 1 server, okay, for 1 action, just like for services, for 1 action you only have 1 possible server, but you can have many action clients. And for example, here in this case, we have 3 action clients that are each sending a goal to the server. And then of course, it's the server responsibility to decide what to do with all those goals. And what you can have also is, in this case, you can see the action client 1 is actually sending multiple goals, okay? So 1 client can send multiple goals, and you can also have several client nodes sending, well, as many goals as you want, and then it's gonna be handled in the action server. All right, and now that you've seen all that, it's time to actually write some code. We are going to develop a simple application to get started. The action server will be responsible to count until a given number. The client will then have to send a number to the server so that the server can start to count. And then in the end, when the server is done, it will send the result back to the client. We are also going to add the feedback, the cancel mechanism, etc., as we progress. But for now, let's focus on the first step we need to do. For an action, just like you did for topics and services, you need to create a definition. So you need to first create an action definition to specify what is the goal you're gonna send, what is the result you expect, and also what kind of feedback you're gonna send from the server. To create the action definition, we first need to create a package, and to create a package, we first need a workspace. So I am in my home directory here, and I am going to create a ROS2 workspace. Okay, and so that's something you should already know how to do. So I'm gonna go quite quick here. So I create a ROS2 workspace folder. In this, I create a source folder, and right here, I'm gonna do colcon build, okay, to just initialize the package. And now we have this build, install, and log folders. In the install folder, we have a setup.bash script. That's right here, that we need to source every time we want to be able to use what we have built with this workspace. So what I will do is I will simply go, so I'm using gedit here, I will go to my bash rc file where you already have those two lines. So the line to source the global ROS2 installation and the line to also get the autocompletion for colcon. And I'm going to add here source and then the path to my ROS2 workspace install setup.bash. Okay, and I'm gonna save that. So make sure you source this after the global installation. Very important. Okay, I save, I quit, and then either I source this setup.bash or I open a new terminal or I source the bash rc, that's gonna be the same. Great, so let's go back here and let's go to our source folder for the workspace, which is now empty. I'm gonna do clear, and let's create a package. So what package do we need? Well, we're gonna create just a normal package to create interfaces. So either you create topics, services, or actions, that's gonna be the same thing. So ROS2 pkg create. And how do we name the package? Well, usually you will name it with first the name of your robot or your application, and then in the end you're gonna put interfaces. Okay, so I'm gonna follow this. Let's say the robot is my robot, and then interfaces. Okay, I'm gonna keep this for the course. That's something that is quite common to do. So I create a package. I'm not gonna put any build type or dependencies here. We're just gonna create a basic package and then we're gonna modify it as we go. So I press enter and we have this new folder. So there is always a warning with the license, no worries about this. And so we have this my robot interfaces. Let's go to my robot interfaces, and that's basically a C++ package. So with a source and include folder plus the cmeclist.txt and package.xml. I'm gonna remove so with this the include and the source. Okay, so now we have nothing, and I'm gonna create MSG, so an MSG folder, an SRV folder, and an action folder. Okay, so in this package we can create topic messages in the MSG, we can create services here in SRV, and we can create actions in the action folder. Okay, we're not gonna use MSG and SRV here, but it's just to initialize it correctly with all the three kinds of communications. And now that I have this, I'm gonna go back to my source folder of the workspace, and here I'm gonna start Visual Studio Code. Okay, so I'm just gonna bring it here, and you should get this. So let's wait for ROS extension to initialize. If you haven't set it up correctly, you can go back to the introduction section of the course where I show you how to do this. But now I'm just gonna go to my robot interfaces package, okay? And I will need to create a new action into the action folder here, and also then set up cmeclist.txt and set up package.xml. I'm first going to create this new file here. So I'm gonna right click here, new file, and I'm gonna name it count until.action. So you can see that what we do is just like we did for messages and services. We're gonna put the name of the action and then dot action. And I'm gonna press enter. And the convention here is to use, as you can see, uppercase for each new word. Okay, make sure you don't put any space, underscore, or anything else in the name. Okay, you just put all the words like this with a new uppercase for each new word. And then dot action. You don't put action in the name of the action. Okay. And as you can see here, so we want the server to count until a certain number. So here with actions, just like you would do with services, usually you will use a verb. Okay, for the name you will use a verb. Here the verb is count. Okay, count until. Okay, so we have our file. Then in this file, I'm gonna put 3 dashes and 3 dashes here. We will have the first thing. So I'm gonna put a comment here, okay, with this symbol. That's gonna be here the goal, and then the result, and then the feedback. Okay, so if you are familiar with services, you know that in a service we put 3 dashes to separate the request from the result. Well, in an action, it's basically the same thing. We're gonna separate the goal from the result, but there is also the feedback, so we just add 3 dashes and 3 dashes. That's how you create an action definition. So what do we put for the goal? I'm just gonna put here a basic type, so int64, and let's say target number. So we want to count until this target number. We're gonna start from 0, for example, and count until this target number. And I'm also gonna put, so a float number, it's gonna be the period, okay, so the period between each count. So let's say I give 10 and the period is 1.2. That means that we're gonna start from 0 and every 1.2 seconds, we're gonna add 1 to the counter until we reach 10. Okay, so that's gonna be the server mechanism. All right, so for the goal, we have an int and a float. Then the result, well, the result is gonna be the reached number. So let's add an int64 and let's name it reached number. So you can see for the convention here, we use all lowercase, and if we want to separate words, we use a underscore. So that's our result. And then the feedback. So the feedback is actually optional. So any field actually is optional. You can send an empty goal if you want, an empty result, an empty feedback. But usually you will at least provide a goal and a result. The feedback is really optional. It depends. Maybe sometimes you don't want to send feedback or you don't need to. But here we're going to send feedback. We're going to send so an int 64 current number. So as we iterate on the counter, we're going to actually send the current number to the client so that the client can know what is happening on the server side. All right, and now the action definition is finished. I'm going to make sure that I save the file, and now I can go to my package.xml. So here I have the basic stuff that I have for every package. With the build tool depend, you can see it's payment.cmake. We're going to keep this. And then we're going to need to add 3 lines. So those 3 lines are the same for, well, that's the same that you had done for messages and services. So build tool, we need build tool depend, and then ROS IDL default generators. Okay, with build tool depend. Then I'm gonna need to add exec depend with ROS IDL. So ROS IDL is the package, the functionality to build messages, okay, for ROS2. So default runtime exec depend. Here it doesn't need to make sense, it's just you need those 3 lines and that's it. And then you can forget about it. And then member of group with ROS IDL interface packages. Okay, so make sure you have exactly those 3 lines. If you want, you can copy and paste them from, well, the code that you can download at the end of this section. You can also easily find them on the internet. If you want to make sure you have the same, that should not be a problem. And once you have those 3 lines, well, you can just close the package.xml because we are not going to need it anymore. Then we're gonna go to the cmakelist.txt. Just gonna, so I don't need this, and I'm gonna clean this a bit. I'm not gonna do build testing And I'm just gonna remove those comments here to make it a bit cleaner. So what do I need to do in the cmake.list.txt? I will need to find, so after find package with amen cmake, I'm gonna add another find package, this time for ROS ideal default generators here, and with required. Then I will add ROS ideal generate interfaces, and I'm gonna put project name like this with $, and then curly brackets project name. So project name basically is gonna be the name here of the package, my robot interfaces, and I will open the parentheses here, and in this I will put each definition, so message, service, or action definition. So each definition I create, I will put them on a new line without any comma. Okay, for now let's finish the configuration. So I put this line here, this line there, and I'm also going to need to do amen export dependencies here with ROS ideal default runtime. Okay, and then amen package. So this, you've probably done it before. It doesn't need to make sense really. It's just some configuration you need to put, and then you can forget about it. And now what we can do, we have this count until action here. So I'm gonna put double quotes here, and I'm gonna put action here because we are in the action folder, and then the name. So basically the path to the file. So count until dot action. All right, I want to save this. And so once you have done all this configuration, all you need to do if you add a new action or a new message or a new service is just to put the new interface here on a new line without any comma. That's important. And then you can just compile again. Okay, so now we should be good. Let's go back to the terminal, and let's go back one step here in the workspace, and I'm gonna do clear here, and I'm gonna do call conn build. And we just have one package, but we can do packages. Select here with the auto completion. So make sure you have correctly put the auto completion on the bash rc in the introduction section. And then we're gonna do my robot interfaces. So it's gonna take some time. Okay, and you can see one package finished. So we don't have much information here, but looks like it's been successfully generated. So I'm gonna source the setup.bash. So I can source it like this. I can also source the bash rc, open a new terminal. Well, I guess now you know how to do this. And then once I have sourced my workspace, I can do ROS2 interface show. And then let's try to find the interface we have created. So the name of the package is my robot interface. And you can see I just press tab here, and I have my robot interfaces action count until. That's where the interface has been created. I can press enter, and you can see I have exactly the definition here that I have created. So if you can find the interface with ROS2 interface show, so if you have the auto completion and if you can print it, it means that you have successfully built it, and then you can use it in your code. If you don't get to this point, then don't go to the next step. Make sure you finish this step. So go back to the first step and do everything again, and make sure you can find the interface before you use it in your code. Hey, it's Edouard, and just a very quick parenthesis here. I hope you find this tutorial useful, and if you like the way I teach, then make sure to check out this 14 hours course to learn ROS2 actions with much more details, plus lifecycle nodes, executors, and components. Alright, and let's continue with the video. We are now going to create the action server for the actions that we have previously generated here. So let's go back quickly on the image here on how actions work. You can see that the client would send a goal, and then the action server will execute the goal and send a response to the result request from the client. So the minimum thing the server has to do is to be able to receive goals, to execute them, and to send a result. That's what we are going to do here. So let's go back here, let's go back to the terminal, let's go back to our workspace in the source folder. So we have the package for the interfaces. I'm not gonna go into this package because this is only for interfaces. I'm gonna create a new package and I'm gonna name it, so let's do ROS2 pkg create. I'm just gonna name it actions py, okay? So actions Python, and then in the next section, we're gonna do the actions cpp, okay, to keep things simple. I will need to provide a build type. So build type here is gonna be element Python because I'm gonna use Python. And then optionally, I'm gonna provide some dependencies. So I'm gonna put dependencies here. Let's put them, so we know that we're gonna need rcl-py because we're gonna write some Python code with ROS2. And we also know that we're gonna use the interface we have created. So we need the dependency to my robot interfaces, okay? So we might need to add more dependencies later on, but at least we know we have those two. So let's just add them right now. I'm gonna press enter, and well, we have this all those logs with the warning, with the license, but no problem about this. Okay, I have my new package here, actions_py. Let's go inside, and we have another folder, actions_py, where we are going to write our nodes. So the only thing we have for now is an init.py file. I'm going to create a new one. Let's call it count until server.py. Okay, let's keep name simple. And I'm gonna make it executable with chmod +x. Okay, so if I do ls, I should see it in green here on Ubuntu. Great, let's go here on VS Code. So I had already opened VS Code, and now you can see we have my robot interfaces and we have actions py with the count until server.py. So we have the node here, and while it's empty, we're gonna start to write some code for this node. And I am not going to start exactly from scratch. I am going to use actually the node OOP template that I gave you. So if you don't know about this, go back to the introduction section as well. So I explain what is this. So now you should also be able to write a node by yourself if you are in this course. And so usually I start with this template, so I don't need to write those 20 lines. It's a bit of a shortcut. We have our class here for the node, and then in the main we init ROS2, we create the node, we make the node spin, and then we shut down. Okay, so what we need to do is just to modify the name of the class. So let's call it count until server node, okay, which inherits from node. And then I'm gonna just put this here as well. I can remove the comments here. And we also need to specify the name of the node in the graph. So let's call it count until server. I will save here. And what I will do is first I will try to include the action that we have generated before. So to include the action, I will do from my robot interfaces dot action import count until. Okay, so the name of the package dot the name of the folder here, then import the name of the action count until. I save, and well, if it is not recognized, so if you continue and you have some error, some import error here, maybe this is because you have generated the action here in the terminal, and you are using VS Code still from a terminal where you didn't set up the environment correctly. Okay, so what I would do if you have just generated an action is to quit VS Code, and then let's go back here. Let's go back to the source folder. Let's make sure we have actually sourced. So let's source the bash AC. So we have sourced the workspace, and then let's open Visual Studio Code again. Okay, and let's wait a bit that things are initialized here. Okay, well, now you can see it turns green. Sometimes it doesn't turn green, but it's still recognized. But as you can see now, I started VS Code from a sourced environment. So now I'm sure that my robot interfaces action is going to be found. If not, if you don't have auto-completion, well, that's not super practical, but that's really not a problem. That's still gonna work. Okay, and now we can create our action server in the node. So how to do that? Well, in the init, after super, I'm gonna say self.count until server. I'm gonna use a trailing underscore for every private attribute that I create here in this course, okay, is equal to, and we will need to actually import. So here I'm gonna do from RCL by.action import action. So you can see we have action client, that's gonna be for later, and we have action server. So I'm gonna do action server. I will need here, so that's a tiny bit different from creating a subscriber or a service server or stuff like that. Here I will need to, so I will create the action server, and inside I will need to provide the node. So the node is going to be self, okay? Self, because that's actually, well, that's the node itself that you are passing to the action server, okay? That's just specific syntax here. Then you need to provide the action type. So what is the action type? It's count until. That's what you have imported here. After the action type, you need to provide the name. So that's going to be the name of the server in the graph. And so what will be the name here? Let's call it count until. The client will have to exactly send the goal to this name here, count until. And then you can see we have different callbacks that we can create. And we're going to create first an execute callback. Okay, to make it a bit more clear, I'm just going to put one argument per line. And I'm going to put execute callback is equal to, and let's create actually a callback in the class. So let's call it, so def execute callback with self, and then we're going to receive a goal handle. I'm going to come back to this just in a second. I'm going to put pass here for now, and I can pass self dot execute callback like this without any parentheses, okay, just the name of the function. Okay, and that's how you create a minimum action server in Python. You pass the node, the type, and the name. You can see this is very similar to topics and services. For actions, you also have the type of interface and then the name of the server so that the client can reach it. And then we have this execute callback, and I'm just gonna add, before we do this, I'm just gonna add a log here, self.get logger with info action has been, so action server has been started. Okay, so when we actually start the node, we have something printed on the terminal, and we know the action server has been started because we have reached this line. So now let's go back to our image here. So the server is going to receive a goal, and actually here there is a callback when we receive a goal to accept it or reject it. But in Python it is optional. So I'm not going to do it right now, we're going to do it a bit later. So what's happening is if you don't implement this callback, well, the goal is automatically accepted. And when the goal is accepted, then the execute callback is going to be called. Okay, so when you receive a goal, you're going to directly go to execute callback, and you will receive here what we call a goal handle. So the goal handle will contain, well, the goal information, and you will be able to handle the goal in this callback. Okay, so what we need to do now in this part, in this action server, in this execute callback, we're gonna execute the action, and we're gonna return the result. And first, I'm just gonna add something here. I'm gonna import actually here from rcl.py.action.server. I'm gonna import server goal handle. Okay, and because that's gonna be the object that we receive here, so I'm just gonna put a colon server goal handle. That's gonna be convenient. Okay, so we know it's a server goal handle type of object, and we're gonna have also the auto completion in the function, so that's gonna be more convenient. So what do we do in this execute callback? Well, the first thing is we are going to get the request from the goal. So request from goal. So basically, if I go here, count until action, we need to get this target number and this period so that we know what we need to do. So I'm gonna put target here is equal to goal handle, So the goal handle we have here, dot request, and then dot target number. Okay, so I use target number here because that's exactly the name we have right here. Okay, and then I'm gonna put period is equal to goal handle dot request dot period. Okay, so by doing this, I don't need to I don't need to write this every time. I just have my target. Actually, just put target number and period. Then, well, we're going to execute the action. So execute the action. Let's put a log here. Let's do self.get logger info executing the goal. So that's gonna be easier for us to debug and to know the flow of the execution. And what I will do is I will start a counter from 0 and then go until the target number, and every time I'm gonna wait the time here, the time of the period. Okay, so quite simple. So I'm gonna create a counter here. Let's put 0, and then let's do for I in range target number. Okay, so from 0 to the target number, we will do counter plus 1, and then we do time dot sleep. So actually I need to import time. So let's do here, let's do import time. I can use time dot sleep with the period. Okay, so you can see that in this callback we're gonna actually make the thread sleep. So that's kind of a simulation of an action that would take some time here, because we could count super fast, but by adding a time.sleep, we simulate the behavior of the robot that's gonna take some time. All right, and basically that's it. We're just gonna count from 0 to the target and sleep by this amount of time. What I'm gonna do also is just add a log here, self.get logger with info, and just put, so I'm just gonna put str of the counter here, so we print the counter every time, just to see what's happening on the server. Good, so we execute the action. So we are here, we have executed the action. What we need to do is to return the result. How to return the result? We will need to do two things. So once we are done, we need to set the goal final state. And I'm gonna come back about the goal final state a bit later, but for now what you can do is do goal handle. So the goal handle is the goal handle you have got in here in the arguments. You can do goal handle dot, you can see succeed. If you do goal handle dot succeed, you said that, well, the goal has succeeded. So we set the final goal state and send the result. And so to send the result in Python, you will need to create. So let's create a result. How do we create a result? That's gonna be, so you're gonna use the count until here. So count until dot result here with an uppercase. You can see we have result, feedback, and goal. So we're gonna create a result. We put some parentheses here, and you can do result dot reached number. Okay, that's what we have specified here. So result dot reached number is equal to the counter. Okay, so the counter in the end should have the same number as the target number. And then don't forget this, return the result. Okay, because the execute callback in Python needs to return the result. If you don't return it, you're gonna have an exception. And let's save that. All right, and the server is now finished. So you can see it's quite simple here. We just create an action server. We specify the type, the interface name, and then we have a callback to execute the goal. So the goal is going to be automatically accepted. And then when we execute the goal, we got a goal handle, which contains the request. Okay, so we get the request here, what we need, so that we can execute the goal. And then once the goal is done, you can see from the goal handle, we can directly do goal handle.succeed, and then create a result and return the result. So now that we have done this, let's actually build and install this node. I'm gonna go to the setup.py, and in console script here, I will just add. So we need to add an executable name. Let's keep things simple and let's do count until server is equal to actions py dot count until server. So count until server here, that's gonna be the name of the file, and then colon main, because we have a main function here that we want to execute. Okay, I'm gonna save this and can quit this file now. And if I go back to the terminal, I can go back to my ROS2 workspace, and let's do a colcon build packages select with actions py. Okay, well, you might have this warning about the setup tool stuff deprecated. It's not really a problem, okay? As long as you see finished and as long as you don't see any other error. Okay, so this actually means that the package is successfully built. Now you can source the workspace and you can do ROS2 run actions py, and you should have the auto completion count until server. And you can see the action server has been started. And I'm not gonna test it right now. What we're gonna do is we're gonna first write the client code, and we're gonna run the server and the client at the same time and see what is happening. The action server is now created and installed. Let's now create the action client. So I'm gonna go back to the terminal. And actually, let's see the image again here. So the action server can receive a goal, execute a goal, and return a result. Now we need to do the other side of the communication, which means we create an action client, which will send a goal, and then which will request the result and wait until the result is sent by the server. Okay, so we need to do this. Send the goal and then get the result. Let's go to the terminal and let's go to our package. And let's create here. So we have the count until server. I'm gonna create count until client.py, make it executable. Okay. And then I have the file right here, count until client. I'm going to use again the template here, the node OOP template, so that we don't waste time to just create the base structure of the node. And I'm gonna name it here count until client node. Okay, so we had the count until server, here it's the count until client. Let's keep things simple. Count until client, and I don't need this anymore. All right. And the first thing we will do is also to import the interface. So from my robot interfaces dot action import count until. Then how to create an action client? Well, you're gonna import from rclpy dot action import action. You see what we did before was to create an action server. Here we create an action client. So from rclpy.action, you import action client. And here in the constructor of the node, you can do, so let's create self count until client here. And that's gonna be action client. So you use the action client you have specified here. And then we need to provide 3 things minimum. So the node, that's gonna be self, again here, because that's what we use here. After the node, we need to provide the type. So the type is count until, and the name is count until, like this. And that's the minimum thing you need to provide. As you can see, it's very important that in the server, you use the same type and the same name as in the client, okay? So if needed, you just copy this name here and paste it here so you don't make any mistake, because if the name is different, of course, that's not gonna work. All right, and that's how you create an action client, so nothing more. But then this action client is not gonna do anything by itself. You need to send a goal. So what I will do is I will create here a method send goal. That's gonna be easier for us, so we can send the goal using this action client. So self, and let's put target number and period. Let's put pass for now. And what we will do to test actually this action client to send the goal is in the main, we create the node. and then we're gonna do node.send goal with a target number, so let's say 6, and then the period, let's put 1.0. So we want to count from 0 to 6, and the period is 1 second. So that should take 6 seconds in total. Okay, so we create the node that's gonna create the action client, then we send a goal, and then we're gonna make the node spin to wait for the result. So what do we do to send a goal? Well, 3 steps. First, we're gonna maybe wait for the server. So wait for the action server. We can do self.count until client.wait for server. Because if you send the goal to a server that is not up already, well, that's gonna fail. So what you can do is to wait for the server. You can provide a timeout here if you want, and then handle the timeout. I'm just gonna say that we wait indefinitely for the server. Then we are going to create a goal. So let's create a goal. And how to create a goal? Well, let's name it goal. That's gonna be, we're gonna use the count until here. So count until dot goal, like this. And we put some parentheses. And then we can do goal dot. You can see we have target number. We have this because that's what we have specified here. Okay. So goal.target number is the target number we got from the arguments here. Target number, and then goal dot what we have period is the period we have specified. Period specified here from the arguments. Great, so we have created our goal. What we need to do now is to send the goal. Let's just put a log self.get logger.info sending goal. I just put a log so it's gonna be easier to see what's happening. You don't need to do it, of course, later on, but for the first time, that's gonna be nice to see what's happening. How to send the goal? Well, it's quite easy. You do self.count until client, so you have your action client, dot send goal. And you can see we have 2 send goal functions here. We have send goal and send goal async. So if I use send goal like this, let's just put like this, you're just gonna put the goal. So we have created the goal, it's quite easy, you just put the goal, and well, you can put other stuff, we're gonna see that later, but for now, that's the minimum code you can write. Thing is, send goal, this is gonna send the goal and block the thread here until you receive the result. And that's quite problematic because what's gonna happen here? You create the node, okay, and then you send the goal. So we have created the node, we send the goal, which means we reach this line here. And then you can see we are supposed to make the node spin. But because we are blocking in this line here, we are still blocked here in the send goal method, which means that the code is never gonna reach the spin. So when we receive the result, actually because the node is not spinning and because we are still stuck here, then we are not going to receive the result. So that's why I'm gonna put not send goal, but send goal async. And we're gonna use send goal async all the time. Actually, the send goal has a lot of issues. And if you look at the official documentation, they also don't recommend you to use send goal and to always use send goal async. So that means that you're gonna send the goal, but that's gonna be asynchronous. So the goal is gonna be sent, and then you're not gonna wait, you're not gonna block here for the result. For this, you will need to add some callbacks, okay? But that's very convenient because then the function will actually exit, and then we can make the node spin and receive the result. Great, so that's the minimum code we could write. I'm not gonna get the result for now. We're just gonna see that in 1 minute. For now, I'm just gonna use the code like this, okay? We wait for the server, we create the goal, and we send the goal. So I'm gonna test this just to see if the goal is actually received by the action server. Okay, so let's make sure that we save the file. I'm gonna go back to setup.py and let's add another executable. So I put a comma here, very important. And then I will define count until client executable from actions py dot count until client. That's the name of the file here. And then the main function. Actually, I have a typo here. Make sure that the name of the file is correct. Okay, now I can exit this file And I'm gonna go back to the terminal, but I'm gonna use terminators so I can have two terminals here. I'm gonna test the server here and the client here. I'm gonna go back to my ROS2 workspace and I'm gonna do Qualcomm build with packages select. That's gonna be actions py, and I'm also going to use the symlink install option. Okay, so that now we have built those two files. With symlink install, and for Python files only, you will be able to, well, just modify the files and not build again. So that's gonna save a lot of time when we develop the application. You need to at least build the file once, okay, so that's why I waited that we have built the two files to do symlink install, but then we can modify the two files as we want and we won't need to build again. So let's build once at least. Okay, and you see we have those warnings about setup tools and stuff like that, but in the end you can see finished, so the package has been successfully built. I'm gonna make sure that I source the install setup.bash, and I'm gonna also make sure that this one is sourced, so I can source the bash rc. That's gonna be the same. Okay, let's just do clear cd and clear. Okay, and let's start the server. ROS2 run actions py count until server. Okay, now let's start the client. ROS2 run actions py count until client, and let's see what's gonna happen. You can see sending goal and then executing the goal 1, 2, 3, 4, 5, 6, and that's it. So on the client side, you can see that what we did is we sent the goal. The server has received the goal and executing the goal. So if we go back here, we have successfully sent the goal because we know that the server has received it. Okay, and you can see we have the log executing the goal. Okay, so we have reached this callback. And then for each number, the server is gonna print something and then return a result. But you can see that for now, well, the result is going nowhere because the client is not receiving anything. We didn't ask for the result actually. So that's what I'm gonna add now. I did it very simple just to show you that, okay, we can just send the goal and forget about the result. That's still gonna work. But then if we want to get the result, we will need to add a bit more code to this. So what do we need to do here? Well, we need to add a callback for this goal. And well, this send goal async is actually going to return a future object, so a Python future object. I'm not gonna do a complete course on future objects, you can also check that by yourself, but the only thing you need to know is that when you have a future object, well, you expect something in the future and you can add a callback, so you can do dot, you do dot on the result, so that's gonna return a future, and you can do that add down callback. So that's going to be a callback that's going to be called when the future is finished. Okay, so when you have a response for that. And I'm going to add a callback here, goal response callback with self, and then we get a future. Let's put pass. And I'm going to put here self.goal response callback. And to make it a bit more readable, I'm just gonna go back to a new line here. I'm just gonna put the backslash and go to a new line here as well with a backslash to say that the line continues. Okay, so you see on the client we do send goal async, and then on send goal async we do add down callback. And this callback, actually this callback is not for the result. In this callback, we are not going to see to receive the result. In this callback, we are actually going to receive the response for this service here. So we send the goal, and then the server is going to say accepted or rejected. And so immediately we're going to receive the response to say if the goal was accepted or not. So here we're going to check if the goal was accepted, and in this case we're going to send a request for the result. And I'm going to create a self here goal handle is equal to future dot result. So that's what you get. You get a goal handle. And to get the auto completion, I'm actually going to add the type here. And the type, I'm going to need to import it here. I'm going to do from RCL py.action.client import client goal handle. Okay, so on the server side, you see we have a server goal handle, and on the client side, we have a client goal handle. That's gonna allow us to basically handle the goal. Okay, so we got a client goal handle here. I'm gonna put client goal handle. You can see with the column here, and then we can do if self goal handle dot accepted. Okay, I'm gonna come back later also to this accepted or rejected. For now, everything is accepted. Okay, so if it's accepted, then we will need to actually do what? We will need to request for the result. So we do self dot goal handle dot get result, and we're gonna use the get result asynchronous so that we don't block the thread again. And this is gonna give us the result. Actually, it's not gonna give us the result. It's gonna give us a future to the result. So same thing, we need to add another callback here, def goal result callback with self and future. We need to do dot, so we do goal handle get result async, and then we do dot add done callback, and we pass the goal result callback. All right, so you can see that's kind of like a chain of callbacks. You send the goal, and then you have future. You add a callback to the future, and you know if the goal was accepted. If the goal is accepted, then you request for the result. You get a future. You add a done callback so that you have the callback here when the result is received. Okay, that may sound a bit complicated, but in the end, you're gonna use this same structure all the time. And how do we get the result? Then the result is going to be future dot result, so like this, but then we have another dot result. Okay, so here you get the result of the future, and then you do dot result here without parentheses. And this result you get here is actually the result containing the fields here. So here we have the reached number, which is an integer. And so I can do, well, let's do simply a log, so self.get logger.info result, and let's just add the result here. So it's gonna be result dot reached number. Okay, so pay attention to the syntax here, it's quite important. You do future.result with parentheses, dot result without parentheses, and then on this result you can do dot reached number. So what's gonna happen here with the image? The client is sending a goal, the server will then reply with accepted or rejected. So you have the goal response callback. Okay, if you can see if the goal is accepted, that's what we are checking here, then we send the request for the result, and the request for the result will then get a response, and in this response you get the result with the reached number. So that's actually in the server here. That's what we do here. We do goal handle.succeed, and then we return the result. You can see that's the counter here. That's the result of the count until action. So this, what you return here, is gonna be sent to this result callback. Okay, let's try again. So I don't need to build, I'm just gonna source just in case. Okay, and then I can run the server again, and I can run the client again, and let's see what we got. So you can see we send the goal on the server, executing the goal 1 2 3 4 5 6, and then you can see at the end, after this, we receive here result 6. Okay, so we have sent the goal, and then we have received a result. And on the server side, we have received a goal, and then we are sending the result. So you can see the communication here is correctly working. We start here, and then we come back, we request the results, and then we get the result. All right, and congratulations, you have written your first action server and action client with Python. All right, that's also the end of this 1-hour crash course on YouTube. I hope you could learn a lot and get a better understanding of how ROS2 actions work. With what you saw here, you should be able to create your own custom action with a server and a client in Python. And this is really nice to get started, but then there are actually many more things about actions that can be helpful when you create a real-life robotics application. So if you like the way I teach, you will love this 14 hours course about ROS2 Intermediate and Advanced Concepts, which contains more than 6 hours of content just for actions. And let's have a quick look inside. So in this course, as you can see, we have 3 sections here on ROS2 Actions. The first one with Python, where we will see, well, what we have seen in this crash course, but we will also go much further with, as you can see, how to send a feedback, how to cancel a goal. We will see different goal policies that are very useful for different kinds of applications. On top of that, you have a complete section on C++ ROS2 actions. So we will do the same thing as for Python, but this time with the C++ specificities. And on top of all of that, we have another challenge. So that's going to be a new application, so a new challenge that I give you. And I also provide a step-by-step solution for Python and C++. All right, so with those 3 sections, you will really become an expert in ROS2 actions. And then, well, this course contains many more things. As you can see, we have also more sections on lifecycle nodes. So this is a very important concept here with a challenge. A section on ROS2 executors, another one on components. Okay, so all those are advanced concepts in ROS2 that are very, very important. And a final project where you will practice on everything. Okay, the actions, the lifecycle nodes, the components, etc., etc. In this course, I also go deep into the why. Okay, so you will understand why we are doing the things that we do, and I give you the best practices right from the start. All right, now thank you for watching, and I hope to see you in the course.